Welcome back, guys. This video is on working with UART transmitter and receiver in Atmega 328P microcontroller. So before, we have discussed how to use the transmitter and receiver without using interrupts. So in this video I'm going to discuss how to use the receive interrupt to receive data in the UART and transmit using the normal way. But if you want to use the interrupt for transmission, you can use that as well. So you can do it on your own. I'm discussing here how to use the receiver interrupt. So again, as we have discussed earlier, in the UCSRB R0B register, in order to enable the transmitter, you have to set this particular TXEN0 bit to 1. In order to enable the receiver, you have to set RxEN0 bit to 1. So if you are going to use the receiver interrupt, so you have to set this RxCIE0 to 1. So receiver interrupt is this one, bit number 7. Transmitter interrupt is this one, bit number 6, TXCIE0. So here in this case I'm going to use RxCIE0. So in my UART configuration, I have to set bit number 3, bit number 4 and bit number 7 to 1. So in the program, what we are going to do is we are going to configure the UART and set our bit 5 of port B to 1. That means turn on the LED attached to pin 5 of port B, and then in the never ending while loop I'm going to wait until something is received, and if that whatever has been received, I'll be transmitting. So how do I receive? I'm receiving at my interrupt service routine for the receiver interrupt. So whenever I receive data, what I'm going to do is I'm going to set a flag and save my data. So this particular flag that I'm setting here, I'll be checking in my main while loop. So if the flag is 1, I'm going to transmit data. If the flag is 0, I'm not going to do anything. So that will be the structure of my program. So how do I configure? In the configuration, of course, I have to set the baud rate. The baud rate is set by UBRR register. UBRR0L and UBRR0H are the 2 bytes of the 16-bit UBRR register. So in that, I'm calculating the UBRR value according to the given equation. So that equation will be in my program. That is given in the datasheet as well. So lower byte is set to UBRR0L and the upper byte is set to UBRR0H, and enabling the receiver, transmitter and the transmitter interrupt. And I'm setting my number of bits of my data frame, number of data bits in my data frame to 8. So that is being set by UCSZ 02, 01 and 00 bits. UCSZ 02 is 0, 01 is 1 and 00 is 1. So because of that, I'm setting these 2 bits in UCSR0C register to 1. So other than these, I'm setting my number of stop bits to 1. So that has to be set to, the particular bit has to be set to 0. So I'm not gonna do anything here. And I'm setting number of parity bits to 0. So the corresponding bits has to be set to 0. Because of that, I'm not setting anything here. Yeah, then I'm enabling the global interrupt by SEI. With this, I finish my configuration of the UART, and then moving on to the writing of the interrupt service routine for the receiver interrupt. So the receiver interrupt vector is USART RX VECT UART receiver vector. So in this, I'm going to set my receiver flag to 1, and I'm going to store my received 8 bits. So this byte will be transmitted later on. So in my main program, again, I'm calling my config function. So in that, I will be configuring my UART. Then I'm setting the data direction of my pin B of port 5, and I'm turning on the LED attached to port B pin 5, and in the never ending while loop, if I have received data, I'll be transmitting it. So if I have not received data, I'm not doing anything. So I'll be running in the main while loop. So in the flowchart there's a small mistake. This one should not be attached like this one should be attached like this to here, right, to here. So because of that, so if nothing has received, so I'll be going into the main while loop. If something has received, then I'm gonna transmit the byte that I have received. So in that I'm transmitting rx, the greater than sign here, and the data, and this one means line end and the carriage return. So here I'll be going into a new line by transmitting these two. I'll be jumping into a new line, so that whatever we have received next will be they will be displaying in a new line, right? So in the simulation, this is the uh, Arduino Uno development board in Proteus, and I have attached one virtual terminal as a transmitter and another virtual terminal as the receiver. So whatever I'm transmitting from the sender, whatever I'm typing in to this virtual terminal will be displayed in the other virtual terminal. So in the main program, let's go to the main program. In the main program, you can see I have set the process speed and I have set the baud rate. So value in the UBRR will be calculated by the equation given using the baud rate. So by this I'll be setting my baud rate and then enabling the UART and the UART transmitter and receiver and the interrupts, setting number of bits in the data frame and enabling the global interrupt. I will not be using this UART receive function. I will be only using the UART transmit function for the transmission. This I have explained before, so simply I will explain now. So here I'll be waiting until my transmit buffer is ready to receive data. So when my transmit buffer is empty, I'll be sending my data to the transmit buffer so that it will transmit my data. So whenever I want to transmit something, first I have to check if my transmit buffer is ready to transmit. So if it is not ready to transmit, then I have to wait in this while loop until it becomes ready. So once it is ready, then I'll be putting my data into the transmit buffer. So that is my transmit function. So whatever I have received here, so whenever I receive something, I will get this interrupts. So with the interrupt, I will be coming into the interrupt service routine. I'm setting the flag to 1 and I'm storing my data. And in the main while loop, as soon as this RS flags becomes 1, I'll be going into this and keep on transmitting whatever I need to transmit. So this is the data that I'm transmitting. These two are just uh, something that I transmit to verify my transmission, so make it clear. And this one is to jump to a new line, and then I'm making my RX flag equal to 0. So until I receive my next packet, I won't be going into this if condition, right? So this is a simple function. So as we have discussed before again, so whenever I'm using a variable in the interrupt service routine, so I'm declaring them as volatile, right? So RX flag is a volatile integer, RX data is a volatile char. In fact, this is a 8-bit variable, right? So this one in fact, if I want, I can make it as boolean, which is 1 bit, or I can make it as uint 8t type, so which is 8-bit. So this one probably will be 16-bit. So that is the function. So in my simulation, I have the LED attached to port B pin 5. I have attached two virtual terminals to the transmitter and the receiver. So when I run the simulation, this is the sender virtual terminal and this is the receiver virtual terminal. So whatever I transmit here will be displayed here with RX greater than sign, right? So that is a prompt in fact. So if I transmit E M B E D D E D space S Y S T E M S, you can see now embedded systems is displayed here. That is what I have typed in this terminal, right? So if I want to type something random, right? See, that is being displayed. I'm typing it in this sender terminal, okay, right? So that is being displayed here. So that is it for using UART and the receiver interrupt in Atmega 328P microcontroller. So it is a pretty simple task. There's nothing much. We have the configuration, first definitions, include files, configuration of the UART, the transmit function and the main function and the ISR or OLA, like very simple tasks. So try it out and let me know how it goes. Thank you.